Namaskar. Welcome to this module on operating units, operation theatres. I am Professor Dr. Anil Diwan, Professor of Architecture and Head of the Department Building Engineering and Management at School of Planning and Architecture. In this module, we shall discuss about operating units. An OT is a specialized facility of a hospital where life-saving or life-improving procedures are carried out on human body by invasive methods under strict aseptic conditions in a controlled environment by specially trained personnel to promote healing and to cure with maximum safety, comfort and economy. Objectives of planning. The main objectives of planning in an OT should be to promote high standards of asepsis, ensure maximum standard of safety, optimize utilization of OT staff and its time, optimize working conditions, patients and staff comfort in terms of thermal, acoustic and lighting requirements. Allow flexibility, facilitate coordinated services, minimize maintenance, ensure functional separation of spaces, provide a soothing environment, regulate the flow of traffic. Principles for designing. The essential principles that should be followed while planning the physical layout of an operating room suite are the exclusion of contamination from outside the suite with proper traffic patterns within the suite and separation of clean areas from contaminated areas within the suite. OTs require specialized planning because surgical facilities represent a central life-saving activity. They can make or break the reputation of a hospital depending on the functional efficiency. OT is a major cost center in the establishment of a hospital and it accounts for appreciable quantum of revenue in the private sector. No single plan suits all hospitals. Design parameters. Operation theatres should be planned so that to ensure avoidance of unilateral hospital traffic flow in the area, convenient functional relationships and communication with the surgical wards, ICUs, CSSD, blood bank, medical imaging and laboratory services. Avoidance of any outdoor source of noise. Provision for future expansions and alterations. If planning for modular theatre, the wall cladding should be galvanized iron, stainless steel panels, joints filled with epoxy and grinded. The final prepared surface should be treated with antibacterial paint. Doors should be of sliding type with minimum 1.8 meters width in areas where patient movement is anticipated, like the operation theatre, pre and post operative rooms. The sliding doors are preferred to double action leaf type since they are more user friendly, save space and prevent air turbulence. Ideally, the doors should be electrically operated, hermetically sealed sliding doors to ensure sterilization and correct air pressure. The main advantages of hermetic sealing sliding doors are that they facilitate quicker, safer disinfection, keep contamination risks under control and facilitate acoustic and noise control. In case of failure of air handling unit, the temperature and humidity levels can be brought within the range more quickly. Corridors should not be less than 3 meters in width to facilitate the movement of trolleys and stretchers. Walls and ceilings should be aesthetically pleasing, non-porous, fire resistant, water and stain proof, seamless, non-reflective and easy to clean. They should not cause a built-up of static electrical charge. They should be jointless or have joints that can be thermo-sealed. Floors should be smooth, non-slip and made of impervious material that is conductive enough to dissipate static electricity but not conductive enough to endanger the personnel from shock. The flooring should either be insect mosaic with the least possible number of joints and copper strips to carry away any static electricity produced, or of jointless conductive tiles. Conductive copper mesh and self-leveling epoxy flooring may be done. The ceiling should be painted with washable paint and corners should be coved to collection of dirt and dust. Taps in the scrub should be knee-elbow operated or preferably electronically controlled, activated by infrared sensors. There should be a power backup with the provision of standby generating sets. In the operating room, aesthetic rooms, recovery rooms, holding areas, the color of walls and ceiling should be such that they do not alter the observer's perception of skin color. This will facilitate patient monitoring and management. An OT should have a facility for high-speed autoclaves, sterilizers to meet the immediate emergency requirement of sterilizing equipment. Essential pharmaceutical storage, including refrigeration facilities, should be available. There should be a waiting room with toilet facilities for the patient's attendants. Pass-through cabinets allow the transfer of supplies from outside the OT. They help ensure of rotation of supplies in storage and can be used only for passing supplies as needed from a clean center core. X-ray film illuminators should preferably be recessed into the wall. There should be emergency communication system that can be activated without the use of hands. Preoperative patient holding areas. This should facilitate movement of both stretchers as well as ambulatory patients not requiring stretchers. Each stretcher station should be of 7.5 meters square and should have a clearance of 1.2 meters on the sides as well as foot of the stretcher to facilitate monitoring and therapeutic management of patients. Post-anesthetic care units. These should contain a medication station, hand washing station, nurses station, storage space for stretchers, supplies and equipment. Additionally, there should be 7.5 meters square space for each patient beds, clearance of 1.5 meters between beds and 1.2 meters between the patient bed sides and adjacent walls should be present. Service areas. This area should include control station located as to permit patient observation of all units into the suite, a sub-sterile area between two or more operating areas for flash sterilizer, sterile supply storage area and hand washing station, scrub facilities near the entrance of each operating room. Dirty utility for collection and disposal of soiled material, clean sterile supply room, operation room, medical gas storage facilities, anesthesia workroom for cleaning, testing and storage of anesthesia equipment. Staff amenities, Separate areas, rooms should be provided for male and female staff containing lockers, showers, toilets and space for donning surgical attire. These areas should be designed to allow one-way traffic, that is, personnel entering from outside the surgical suite to change and move inside. Duty rooms should be provided for nurses and doctors. Medical gases. The main storage area for medical gases should be outside the facility, and there should be a provision for additional separate storage for reserve gas cylinders to meet at least one extra day's requirement. Anesthetic workroom. This should provide space for anesthetic trolleys and equipment and should have direct access to the circulation corridors and ready access to the operating room. It should be designed to facilitate cleaning, testing and storage of anesthesia equipment. It should contain workbenches, sinks, racks for cylinders. It should also have sufficient power outlets and medical gas panels for testing of equipment. Blood storage. There should be a provision for adequate refrigerated blood storage. Clean storeroom. This should be clean workroom where clean sterile materials are stored and arranged prior to their use in the operating room. Its functions include the storage of instruments and materials, holding of sterile supplies and packs, preparation of dressing and instrument trolleys, and storage of drugs if the theatre sterile supply unit TSSU is not available. Flash sterilization of unsterile specialized instruments is also carried out here. It should be located in such a way that it has direct access to the operating rooms and the sterile supply, theatre sterile supply unit. Positive pressure is to be maintained relative to the adjoining rooms. Laboratory. An area for the preparation and examination of frozen section may be provided. Depending on the operational policy, this may be part of the main laboratory. Storage. Adequate storage rooms for equipment supplies utilized in the operating unit should be provided. The design should allow ease of access to the storage areas for delivery of consumables. Controlled access from the external corridors is recommended. Storerooms are best designed in an elongated rectangular shape to allow easy access to all items. Part of the room may be utilized as an area for testing operating equipment. For this purpose, a separate room, biomedical engineering room, may also be planned. Storage bays that are preferably recessed into the corridor walls should be provided for equipment such as stretchers, portable X-ray machines, etc. Zoning. Zones are areas of varying degrees of cleanliness in which the bacteriological count progressively diminishes from the outer to the inner zones, operating area, and is maintained by differential decreasing positive pressure ventilation gradient from the inner zone to the outer zone. Protective zone. The areas included in this zone are reception, waiting area, trolley bay and changing rooms. Clean zone. Areas included in this zone are pre-operative room, recovery room, plaster room, staff room and clean store. Sterile zone. Areas included in this zone are operating suite, scrub room, anesthesia. Disposal zone. Areas included in this zone are dirty utility and disposal corridor. Supply air. Supply air to the operating rooms should be delivered at high level in a way that it minimizes recirculation of potentially contaminated air and provides the cleanest practical air supply over the operating table area. The direction of airflow within the operating units should always be from clean to less clean areas, that is from the operating room and setup room through intermediately adjacent inner anterooms, scrub up and aesthetic rooms to the entrance foyer, recovery, changing and post-operative cleanup rooms. Graduated negative pressurization relative to the pressure in the areas adjacent to the operating unit is recommended. It should range from 10 pascals positive in the operating rooms to slightly negative pressure in areas like entrance foyer, recovery and change rooms, and slightly more negative in cleanup rooms. This should be achieved by using carefully balanced supply air and exhaust air systems. Airflow into the operating unit should be by means of a distribution system that provides a flow of clean air over the operating area first and then away from it. Entry of air should be from the ceiling to deliver a downward air movement. Total circulated air quantity should not be less than 15 air changes per hour when the supply air filters are at their maximum pressure drop. Operating room relative humidity should be maintained within a range of 45 to 60%. The operating room temperature should be adjustable. Range is recommended to be 21 degrees Celsius to 24 degrees Celsius to enable individual temperature, infection and odor control. Each operating room or pair of operating rooms should be served by dedicated air conditioning units, which may also serve that the operation rooms adjacent sterile support rooms. Exhaust arrangement. Exhaust registers should be located so that the whole room effectively scavenged, particularly at the floor level. Special arrangement such as position of balanced counterweight flap to each low level exhaust point should be installed to prevent an outflow of air from an exhaust point due to adverse air pressure when opening any of the operating room doors. Extraction of relief air and, if incorporated, return air must be located at low to mid level. Supply air outlets must be located directly above the operating table. Exhaust relief air should be extracted at a point as close as possible to the anesthetic delivery trolley to remove anesthetic gas leakages from the work area while ensuring good airflow through the room. Low level of exhaust shall be extracted at 200 millimeters above the floor level. When the hood is installed in an operating unit between the cleanup and setup rooms, it is best that it is a pass-through design. Relative position of pressurization of the chute shall be adversely affected when either door is open. Design requirements for ultra clean air systems, UCA systems. UCA systems provide sufficient filtered air moving in the correct direction to effectively remove the bacteria dispersed by the operating team. The airflow from the final filter must contain more than 0.5 colony forming units per cubic meter of air. Airflow downflow system. The airflow at 1 meter from the supply air outlet must have a minimum average velocity of 0.3 meters per second and at working height not less than 0.3 meters per second. Operating rooms where lasers are being used should have adequate suction evacuation control for the plum generated, as it contains tissue particles, carbon debris, hazardous chemicals, bacterial and viral particles which are potential hazards to the health of personnel in the operating room. The OT should have less than 35 colony forming units CFU of bacteria per meter cube of air and less than 1 CFU of Clostridium perfringens or Staphylococcus aureus. The maximum germ contamination should be not more than 10 CFU per meter cube in the room air in theatres used for transplantation of organs, heart and bone surgery. Ventilation. The ventilation system is essential for protecting the surgical side of using particle displacement dynamics of properly directed purified air movement. Central air conditioning should ensure temperature range of 21 to 24 degrees Celsius with 45 to 60% humidity levels. A minimum of 15 air changes per hour should be ensured. It is preferred to have 100% fresh air. The theatre should maintain a positive pressure. Controlling of pressure is adhered to by providing pressure release dampers at the time of opening and closing of doors. During surgical operations, the concentration of bacterially contaminated airborne particles in the operating theatres averaged over any 5-minute period should not exceed 180 per meter cube, and special types of surgical operations like orthopedic, transplantation procedures, higher standards of air cleanliness must be ensured. Lighting. General illumination is furnished by ceiling lights. Lighting should be evenly distributed throughout the room. The anesthesiologist must have sufficient light to adequately evaluate the patient's skin color. Electrical wiring should be concealed. Conduit. Lighting, both natural and artificial, should be of appropriate illumination. Isolated power systems help prevent sparks from igniting flammable anesthetic and also help to protect patients and personnel from shock. Ground fault circuit interrupters GFCIs may be utilized, which are designed to shut off the electrical power within a few milliseconds of occurrence of a ground fault, thereby preventing serious electric shock. To minimize eye fatigue, the ratio of intensity of general room lighting to that of surgical suite should not exceed 1.5, preferably 1.3. The contrast should be maintained in corridors and scrub areas as well as the room itself, so that the surgeon becomes accustomed to the light before entering the sterile field. Color and hue of the lights should be consistent. The overhead operating light must provide an intense light within a range of 50,000 to 1,25,000 lux into the incision without glare on the surface. The light may be equipped with an intensity control. Provide a circular light pattern and focus appropriately for the size of the incision. Fixture should provide focused depth to reflecting light to illuminate both the body cavity and general operating field. Be shadowless. Multiple light sources and or reflectors decrease the shadows and produce blue-white color of daylight. be freely adjustable to any position or angle by having vertical and horizontal range of motion, should enable easy cleaning, should be aerodynamically designed to facilitate airflow, produce minimum heat. Halogen bulbs generate less heat than other types. Auditory effects. Sound levels in OT should be limited to 25 to 35 decibels. The reverberation time in the OT should be reduced to below 1 second. Fire safety. Both ionization and optical fire detectors should be provided in the operating theatres. Instead, heat detectors, since equipment oriented operation theatres are likely to create more smoke than heat in the eventuality of fire. Hydrants and fire extinguishers should be provided. The fire exit route should be clearly identified, earmarked and well illuminated. Modular systems. Modular systems, which consist of prefabricated units for operating suites, complete with integrated mechanical and electrical services including air conditioning, are available and should be utilized. Modular industrialized systems are increasing with the number of hospitals coming up. These consist of factory-made components for operating suites, complete with integrated mechanical, electrical engineering and services including air conditioning. The advantages of these modular theatres is that they are pre-designed and engineered with guaranteed performance and shorter construction time. The vertical laminar flow system with operating enclosure of these specially designed operating theatres are designed to reduce the airborne infection to an exceptionally low degree. Conclusions. The operating unit provides a controlled climatic environment for the operative and pre-operative care of patients undergoing diagnostic and surgical procedures under anesthesia. Surgical practices in the past were not so sophisticated as in the present. The introduction of safer practices in anesthesia, surgical advances, integration of computerization system including robotic surgery have necessitated the modernization of operation theatres. The design of the operating theatre offers a challenge to the planning team to optimize effectively by creating conducive environmental conditions and functional traffic flows flexibility for the future expansion. Thank you. Namaskar.